Sometimes when we write Lewis structures, there's more than one good Lewis structure that we could write. And so let's look at SO2 and write a Lewis structure for SO2. So we said that the first thing we have to do is write a skeletal structure, and that molecules tend to be symmetrical. So we're going to put the sulfur in the middle and the oxygens on each side. And then we have to figure out, well, how many electrons do we have to mess around with here? Well, the sulfur brings 6 because it's in period 6. I'm sorry, group 6. And the oxygen each brings 6. There's 2 of those. And so I believe that's 18. So we have 18 valence electrons that we can represent in this structure. Well, we need at least one single bond between these atoms. So there goes 2, 4 electrons. And then let's work on lone pairs. So we've got 4, 6, 8, 10, 12, 14, 16, 18. So we've used up all of our electrons. Is everybody happy? No, one of the oxygens is not happy. Oxygen only has 6 valence electrons, and it needs 8 to have an octet. So this isn't good enough. We ran out of electrons. That's when you make multiple bonds. Don't go throwing multiple bonds in there until you realize, hey, wait a minute, we don't have enough. Because, in real life, what happens when you don't have enough? Well, then people have to share, right? You don't have enough copies of the handout. Well, then people have to share. So we have to share more when we don't have enough electrons. So what we'll do is we will take a lone pair off of here and put it as a bonding, put it as a bonding pair in here. Now, the sulfur has 6 electrons from the bonds. Let's point to those. So it's got 2, 4, 6, 8. The oxygen has 2, 4, 6, 8. And the other oxygen has 2, 4, 6, 8. Everybody's got 8 valence electrons. Everybody's good. Okay, this is a good Lewis structure. But why did we give the double bond to the oxygen on the right? Why didn't we give it to the one on the left? Could we? We could. So we can draw 2 Lewis structures for this guy. So we could draw it like this. Well, let's try to make them somewhat similar. Bless you. That's a good Lewis structure as well, right? All the atoms have an octet. We've got the right number of electrons. So these 2 structures are equally correct. So which one's right? Can they both be right? They can't both be right. You can't have a double bond between the sulfur and one oxygen and a double bond between the sulfur and the other oxygen. What actually exists is something that's between these 2. So neither one of these is actually correct. The real molecule is between these. Either of those would predict that the sulfur dioxide molecule has 2 different kinds of bonds, one double and one single. But when we examine the actual molecule, we find that the bonds between the sulfur and the oxygen are the same. And we can investigate that in different ways. One of the things we can do is we can measure the length, the distance of that bond, and we find that they're the same. A double bond is shorter than a single bond. And so by measuring bond length, we see, wait a minute, those are the same. So we call these resonance structures. What it really is that each of those bonds is like a 1.5 bond. Okay? And Lewis theory gives us no way to understand how that is. There's another theory called molecular orbital theory that if you take Chem 1A, you'll learn about, and that explains why that happens. But we don't want to learn about that right now, do we? No, this is good enough. So the bonds are equivalent, and so what we do in Lewis theory to account for this is we draw both of the structures, and then we put a double-headed arrow in between. So resonance makes you think of something vibrating, right? So you can kind of think of, well, going back and forth between these two. It's the true structure is between. It's not either one of those, it's in between. So that's what resonance is. So there'll be some questions that may ask you, well, how many resonance structures there are, or draw the different resonance structures for this molecule. Anytime you have a molecule where you have more than one of the same element, see here we have 2 oxygens bonded to the sulfur. Or what if we had 3 or 4? But you have 1 double bond and the rest single bonds. Well, then the resonance structures are just giving everybody a turn to have that double bond. So in this structure, the double bond was on the left, and on this one, we give it to the other oxygen. If there was another oxygen, we could draw a 3rd resonance structure and give the double bond to that one. I think we have an example. Yes, here's an example. Write the Lewis structure for the NO2- ion. What's the name of this ion? You can't forget all that chapter 5 stuff. Nitrite. Okay, nitrite. So first thing is a skeletal structure. So, yeah. First thing is to put it into drawing mode. That helps. Skeletal structure. It's just going to be a day. It's going to be a day. That's what happens when you have 3 hours of sleep. So put nitrogen in the middle, oxygen on each side. I'm going to start over because that's too big. Okay, we're just going to be it. The drawings are going to be ugly today. I'll just apologize now. How many valence electrons? Well, nitrogen has 5. We have 2 oxygens. They each have 6. And we're getting these numbers from the group number in the periodic table. What do we do with that negative sign? We add 1 electron. The overall thing has a negative charge because it's got 1 extra electron. So we're going to add 1. 1. Yeah. Okay, so that's going to end up being 18, right? 18 valence electrons. So we'll start by putting a bond in between, and then we go with our dots. So that's 2, 4, 6, 8, 10, 12, 14, 16, 18. We ran out. This ends up being a lot like the SO2. Don't have enough. We need to share more. So I'm going to take the electrons, that one of those lone pairs off, and share it between those 2 atoms. Now everybody has an octet. We're not quite finished because we need to put brackets around this. If you have an ion, you need brackets. Otherwise, you don't. Now, what's the other resonance structure? Let's give the double bond to the other oxygen. We're going to draw the same thing, but we're basically going to draw the mirror image. We're going to flip it. So I'll put nitrogen in the middle and oxygen on each side. But this time we're going to put the double bond on the left and the single bond on the right, and put those valence electrons around. And then we need brackets. Those are showing that this whole structure together has a -1 charge. And then we show that they are resonance structures by drawing a double-headed arrow between them. If there was a third one, you could go horizontal, or you can bend them around, and you could draw the other one below, and you just string them together like that. But this one, there's just the 2. So those are the 2 resonance structures for the nitrite ion. Any questions? Yes?
So resonance structure is just the line in the middle with the 2 arrows?
Resonance structures are 2 structures that are essentially the same, but they're just the double bond, or sometimes there's a triple bond. is given to a different atom of the same element. And we indicate that with the double-headed arrow in between. We draw both structures, or 3 or 4, however many there are, and then we connect them with the double-headed arrow. Any other questions? Resonance is not a huge deal. Drawing Lewis structures is important.